Hello everyone, and welcome again to my How To Education channel. As I promised you last week, today we are going over the derivative rule for the tangent u function. After watching this video, don't forget to leave me your feedback. Let's suppose that there is a function f of x of the form f of x equals tangent u of x, such that u of x is another function of x. The derivative of f of x in this case will follow the general format f prime of x equals u prime of x times secant squared u of x. That is, the derivative of u of x multiplied by secant squared u of x. Let's say, for example, that f of x equals tangent x. We know that the derivative of x is equal to 1. Thus, f prime of x equals 1 times secant squared x, which is secant squared x. Remember that, by definition, secant x equals 1 over cosine x. Therefore, secant squared x equals 1 over cosine squared x. Thus, we can also write the derivative of tangent u of x as u prime of x over cosine squared u of x, which is the derivative of u of x multiplied by 1 over cosine squared u of x. Let's use the previous example in which f of x equals tangent x. We know that the derivative of x is equal to 1. Thus, f prime of x equals 1 over cosine squared x times 1, which is 1 over cosine squared x. If I were you, I would write the solutions of each one of these exercises before taking a look at the upcoming slides. F of x equals x tangent 3x. The given function is a product of two other functions, both in terms of x. Thus, it follows the format f of x equals g of x times h of x, where g of x is x in this case, and h of x is tangent 3x. The derivative of f of x is f prime of x, which is equal to g prime of x times h of x plus h prime of x times g of x. If g of x is x, then g prime of x is 1. If h of x is tangent 3x, then h prime of x follows the general format h prime of x equals u prime of x secant squared u of x. If u of x is 3x, then u prime of x is 3. Therefore, h prime of x is 3 secant squared 3x. As mentioned before, the derivative of f of x is f prime of x, which is equal to g prime of x times h of x plus h prime of x times g of x, which is equal to f prime of x equals 1 times tangent 3x plus 3 times secant squared 3x times x. Thus, f prime of x equals tangent 3x plus 3x secant squared 3x. F of x equals tangent x, all of it to the power 10. The given function is of the format f of x equals a to the power 10, such that a is a function of x. In this case, a equals tangent x. Thus, the derivative of f of x follows the chain rule format. F prime of x equals 10 times a to the 9 times a prime. If a is tangent x, then a prime equals secant squared x. Therefore, f prime of x equals 10 times tangent x to the power 9 times secant squared x. F of x equals tangent 5x. The given function is of the format f of x equals tangent u of x, such that u of x is 5x in this case. Thus, its derivative follows the format f prime of x equals u prime of x secant squared u of x. If u of x is 5x, then u prime of x is 5. Therefore, f prime of x equals 5 secant squared 5x. F prime of x can also be written as 5 over cosine squared 5x. F of x equals 7 tangent x to the power 9. The given function is of the format f of x equals c a to the 9, such that a is a function of x. In this case, a is tangent x, and c is a constant. In this case, c is 7. Thus, the derivative of f of x follows the chain rule format. F prime of x equals 9 times c a to the power 8 a prime. If a is tangent x, then a prime is secant squared x. Therefore, f prime of x equals 9 times 7 tangent x to the power 8 secant squared x, which is 63 tangent x to the power 8 secant squared x. F of x equals tangent 2x minus 3. The given function is of the format f of x equals tangent u of x, such that u of x is 2x minus 3. Thus, its derivative follows the format f prime of x equals u prime of x secant squared u of x. If u of x is 2x minus 3, then u prime of x is 2. Therefore, f prime of x equals 2 secant squared 2x minus 3. F prime of x can also be written as 2 over cosine squared 2x minus 3. F of x equals x to the power 11 tangent 1 over 10x plus tangent 3x minus 1 over 5. The following function is a sum of two other functions. Thus, in order to find its derivative, we apply the sum rule. That is, we find the derivative of each function alone and then add them together. The first function is x to the power 11 tangent 1 over 10x, which is the product of two other functions, x to the power 11 and tangent 1 over 10x. Thus, in order to find the derivative of x to the power 11 tangent 1 over 10x, we apply the product rule. Let g of x be x to the power 11 and h of x be tangent 1 over 10x. If g of x equals x to the power 11, then g prime of x equals 11 x to the power 10. If h of x is tangent 1 over 10x, then h prime of x is 1 over 10 secant squared 1 over 10x. The derivative of x to the power 11 tangent 1 over 10x will then equal to g prime of x times h of x plus h prime of x times g of x, which is 11x to the 10 tangent 1 over 10x plus 1 over 10 x to the power 11 secant squared 1 over 10x. The second function is tangent 3x minus 1 over 5, which is of the format tangent u of x, such that u of x is 3x minus 1 over 5 in this case. Thus, its derivative follows the format f prime of x equals u prime of x secant squared u of x. If u of x is 3x minus 1 over 5, then u prime of x is 3. Therefore, the derivative of tangent 3x minus 1 over 5 is 3 secant squared 3x minus 1 over 5. Lastly, the derivative of the whole function x to the power 11 tangent 1 over 10x plus tangent 3x minus 1 over 5 is equal to 11 x to the power 10 tangent 1 over 10x plus 1 over 10 x to the power 11 secant squared 1 over 10x plus 3 secant squared 3x minus 1 over 5. This is it from math for this week, but if you have reached the end of this video, it is because the content is helpful to you somehow. If this is the case, then don't forget to give your friends and acquaintances the opportunity to have access to these videos by liking, sharing, commenting, and subscribing to this channel. We will be continuing with some derivative rules for further trigonometric functions next Monday, but before that I will see you all on Wednesday with some economics content. Thank you so much.